Hey guys, welcome to Lesson 4, Applications. Applications is just another name for worded problems or problems that are a little bit more difficult than the really straightforward ones we encountered in the previous lessons. So there are three main steps that we follow to solve questions on applications. Number one, we draw a diagram if the question doesn't already have a diagram. This assists us in eliminating minor errors. Then we choose the appropriate formula, whether it's to find the hypotenuse or to find the unknown shorter side. And finally, we put it all together and we solve. First question, we have a rectangle with sides 3 centimeters and 4 centimeters, and we need to find the diagonal there. But we're not after a rectangle, we're after triangles. Triangles are what enable us to use Pythagoras' theorem. So I use the properties of a rectangle to label the opposite side. In this case, the opposite side is 4 centimeters. I get rid of that second triangle because it's just confusing me. Now I have a question that is exactly the same as something I would have encountered in lesson 2. So I write my formula, c squared equals a squared plus b squared. I substitute my sides 3 and 4 and I get c squared is 25, c is the square root of 25 or 5 centimeters. The second question says a 10-meter ladder leans against a wall. The base of the ladder is 4 meters away from the wall. How far up the wall does the ladder reach? There's a lot of information here, so let's unpack it step by step. Firstly, drawing a wall. A wall in maths is really easy to draw. It's just a vertical line. So let's do that first. Secondly, it says a 10-meter ladder leans against the wall. So we're going to draw a line diagonal leaning against the wall. And that's going to be the ladder. And we're going to label that as 10 meters. And finally, it says the base of the ladder is 4 meters away from the wall. That means that if I go along the ground, there's going to be a gap of 4 meters. So I join the ladder and the wall along the ground and I label that as 4 meters. So the question says, how far up the wall does the ladder reach? That means that I need to find the distance up the wall, which I've labeled x. This means it's the shorter side, so I write the appropriate formula, a squared equals c squared minus b squared. That means x squared equals 10 squared, take away 4 squared. This is 84. So x is the square root of 84, or approximately 9.2 meters to 1 decimal place. Don't forget your units. Question 3 is another long question. It says two 6-meter wires are connected to the top of a flagpole and to the ground, providing support. On the ground, there is a 2-meter gap between the base of the pole and the wires. What's the height of the flagpole? So let's start by drawing a flagpole. Similar to a wall, a flagpole is just vertical. So I'm just going to draw a vertical line. That's going to be my flagpole. Then it says two 6-meter wires are connected to the top of the flagpole and to the ground. So I'm going to draw one line going away from the top of the flagpole to one side, and similarly I'm going to draw it on the other side as well. These are the two 6-meter wires. Okay, it also says on the ground there is a 2-meter gap between the base of the pole and the wires. That means between each wire to the vertical pole in the middle, it should be 2 meters. So I draw the ground and then I label it 2 meters between one wire and the pole and 2 meters between the second wire and the pole. And don't forget to write that the wires are 6 meters each and the flagpole is what you need to find, so we'll label that as X. This gives us 2 triangles, but we only need one. So we can ignore the second triangle and just focus on one of the triangles. It's the shorter side that we need to find, so we write the appropriate formula. A squared equals c squared minus b squared. X squared equals 6 squared minus 2 squared, which is 32. this means that x equals the square root of 32, which is approximately 5.7 meters to 1 decimal place. Don't forget your units. This brings us to the last question that we're going to take a look at. This looks quite complicated. It's got a lot of lines inside a circle, so we're just going to start with the information that's given to us. And it says here that C bisects PQ. So we find PQ. Bisects means cut in half. That means that either side of it should be equal. Next up, the information that's given to us says between O and C, it is 12 millimeters. So we write 12 millimeters there. I'm going to leave the units out just because it takes up a bit of space there. Next up, it says between R and C, it's 49 millimeters. So R's at the top, C's down the bottom. Between that entire distance there, it's 49 millimeters. But I know that between O and C, it's already 12. That means that the remaining distance between O and R must be 37 to make that total distance 49. So I fill that in. So far, I don't seem to have enough information to solve this question, so I need to look at some other properties of a circle. It turns out that in a circle, there's a very important property, which is that all the radii of a circle are equal. A radius is from the center of a circle to the circumference. All of them are exactly the same. That means OP, OR, and OQ are all exactly the same distance. But we know that OR is 37. That means OP and OQ must also be 37. So now that I've input all the information that I can, I look for a right angle triangle that I will be able to use. And I found one, OCQ. So I'm going to redraw that over here on the right hand side, just to make it a little bit bigger for myself and easier to see. And once I do that, I can see that it is the shorter side that I need to know. So I write my formula, a squared equals c squared minus b squared. So x squared equals 37 squared minus 12 squared, which is 1,225. So x is the square root of 1,225, which is 35 millimeters. Don't forget the units there. So that means between C and Q, it is 35 millimeters. But we also know that between C and Q is exactly the same distance as between P and C. So that means that if I want to find the total distance from P to Q, I have to do 35 plus 35, which gives me 70 millimeters. And that's it for lesson 4. Thank you very much.